Welcome dear friends, Class 8 Physics.
Myself, Zainab Bahari. Chapter 7, Sound. Part 1, Propagation of Sound, Terms related to wave and representation of wave. Dear students, sound is a form of energy which produces sensation of hearing in our ears. Do you know how the sound is produced? Let us see one activity. Here, this is a rubber band with me. Here, I am going to stretch this rubber band and I will pluck the one string of rubber band. Just observe it. What do you see? It is moving from its place to and fro. And in this, if you will hear, you will be able to listen the sound. So, what do you get? Right. Sound is produced when a body vibrates. Thus, each source of sound is a vibrating body. Each source of sound is a vibrating body. We can say when body vibrates, it produces sound. The another important thing, sound needs a medium for its propagation. It means if there is no medium, sound will not be able to travel. Means sound cannot travel in vacuum. The next important thing, sound travels in all kinds of media, whether it is solid, liquid or gaseous medium. We can say that the speed of sound is more in solid, less in liquid, and it is still less in gaseous state of matter. The speed of sound in iron is approximately 5000 meter per second, while in water it is nearly 1500 meter per second, and in air it is nearly 330 meter per second. But the activity we have seen, just watch it once more in this animation. On plucking the stretched rubber band, we have observed the sound is produced. Let us observe a small animation to see the propagation of sound through different media.
Sound is a vibration that is moving through a medium. When we strike a bell, it will begin vibrating. These vibrations will cause movements to the nearby air molecules. The vibration of molecules nearest the bell will cause neighboring molecules to vibrate, which in turn will cause their neighboring molecules to vibrate. In this way, the vibrations will spread out from the bell in the form of waves. If we happen to be in the range of these waves, we'll hear the sound emanating from the bell. Meanwhile, the sound waves will continue spreading out until they lose their energy. Sound requires a medium to travel through, meaning molecules or particles are necessary to carry the sound wave. The vacuum of outer space has no molecules, and so sound waves cannot travel through space or in a vacuum. The propagation of sound won't be the same in all media. Let's look at this by comparing how sound propagates through gases, liquids, and solids. In a gaseous medium, such as the air around us, the molecules will be far apart from each other. If sound waves begin in the air, they will take some time to cause vibrations in the surrounding air molecules. Compared to gases, the molecules in liquids, such as water, will be a bit more closely arranged. Because there are more molecules to vibrate, sound waves require less time to move through the molecules of a liquid. In solids, such as an iron rod, the molecules are much closely packed than they are in either air or water. This means the sound waves will require much less time to cause vibrations through the molecules, allowing them to travel quickly and for a longer distance. Based on the molecular arrangements of different media, sound will travel more slowly through the air and much more quickly through solids.
Let us move for the next point. Propagation of sound in air. As we know, when a body vibrates, the particles of the medium also start vibrating. During vibrations, the kinetic energy of particles changes into potential energy. It means when a body starts to vibrate, it pushes the medium particles. Due to this force, the particles in surrounding gets energy. That is, kinetic energy of particle increases and they starts to move to and fro. They pushes to the neighboring particles and again they comes back. It means continuously the kinetic energy of particles increases and decreases. When the kinetic energy decreases, their potential energy increases. Means here the continuous change of kinetic energy and again back to the potential energy between the particles takes place, which leads the movement of particles. And this is only the reason sound propagates from its place. As well as we can say sound is a form of energy. So you can note it down. During vibrations, the kinetic energy of particles changes into a potential energy and potential energy back into the kinetic energy. This is why sound is called as a form of energy. And the similar way, when a source of sound vibrates, it creates a periodic disturbance in the medium near to it. The disturbance then travels in the medium in form of waves. Let's observe this phenomenon. Of propagation of sound wave in air.
That's right. I told him.
We hear sounds all around us, but have you ever wondered how we hear them? Let's observe this. Let us take an example
Of gong. When a beater strikes a gong, it starts to vibrate.
When it vibrates, it disturbs the surrounding air particles. Just observe air particles with the help of magnifying glass. Air particles close to the gong gets disturbed due to the motion. They get displaced and they pushes to the particles next to them and they comes back again. This continues till the sound reaches to our ear. Here, actually particles are not reaching to your ears, but they are making the movement to and fro. From their mean position, they slightly get moved forward and backward. And the sound propagates. Particles remain there only. And when this happens, at that time, surrounding air gets depressed, causing the high pressure area called as compression. The compressed air spreads down and low pressure region creates that's called as rarefaction. This causes the series of compression and rarefaction, and these alternate compression and rarefaction causes the propagation of sound. So from this we concluded that sound is propagated due to the pressure variation and density variation of the particles of that particular medium. And these series of compression and rarefaction caused due to low pressure regions, that is rarefaction, and high pressure region, that is compression, makes the sound wave to propagate. Dear friends, let us move to study some basic terms related to a wave. Here comes the first definition, that is amplitude of sound wave. The maximum displacement of the particle of medium on either side of its mean position is called as the amplitude of wave. Dear friends, dear friends, when an object starts to vibrate, it moves to and fro from its mean position. So the maximum displacement from its mean position, the maximum displacement of the object producing sound from its mean position is called as amplitude of sound wave. So here you can note down the definition of amplitude. The maximum displacement of the particle of medium on either side of its mean position is called as amplitude of wave. It is denoted by the letter capital A. Dear friends, note down its SI unit is meter. Since it is displacement, its unit is meter. Here we come next to wavelength. The distance traveled by the wave in one time period of vibration of particles of medium is called as wavelength of that sound. And wavelength is denoted by the Greek symbol lambda. Its SI unit is meter. Since this is the length, it is also measured with the help of unit meter. Next is time period. So the time period is the time taken by a particle of medium to complete its one vibration. This is called time period of the wave. It is denoted by the letter capital T. Its SI unit is second. The next important definition is frequency of sound wave. The frequency of sound wave is nothing but the number of vibrations made by a particle of medium in 1 second. And this is denoted by the small f, letter small f. Its SI unit is hertz. Dear friends, let us see the definitions once again. So as we know, sound is produced due to the vibration or oscillation of medium, particles of medium from their mean position. You can see this is the mean position and the wave got created due to the maximum up and maximum down movement from its mean position. While here, this is the maximum position of its compression and maximum displacement of medium particles in the rarefaction. So here, this maximum distance from its mean position is nothing but the amplitude. So here, maximum height above or below the mean position is nothing but amplitude of the sound. So as the sound propagates, it moves upward and downward, producing the up position, the lobe upward called as crest, and throat. Here, the compression and rarefaction. So in this case, we can say the length of successive crest and throat. This one, complete crest and throat. This is the wavelength. In this case, if you start from the compression and rarefaction, so this complete compression and rarefaction, so this length of sound is called as wavelength. If you consider from here, this and this complete length is the wavelength of the sound. So I hope you understand the definition of wavelength, both the types of the waves of the sound, length of successive crest and throat or length of successive compression and rarefaction is called as wavelength of that sound. And it is denoted by the Greek letter lambda. Its SI unit is meter. Next term is time period. Let us consider the complete wave cycle. So here, complete one oscillation consisting of crest and throb. So this complete wave cycle. While in this case, the compression and rarefaction, this complete wave cycle. This is the one wave cycle. So the time which is required for completing the one wave cycle, the one complete wave cycle in both the types of waves, transverse as well as longitudinal waves, is nothing but the time period. So here we can say, in this case, here total 1, 2 and 3 complete waves we can observe. And if you look here, this is one wave and two waves. In this case, you can see two wave cycles. So the time period is time taken by the oscillating body to complete one wave cycle. So how much time is required to make one crest and throw? That is the time period. In this case, the time required for completing one compression and rarefaction, that is the one wave cycle, is time period. And time is denoted by the letter capital T. Its SI unit is second. The next definition is frequency. You can see here in the first case, in 1 second, the number of waves formed are 1, 2 and 3. The wave completes 3 wave cycles in 1 second. In the second case, 1, 2, 3 and 4. 4 wave cycles are formed in 1 second. While in the third case, if you will look carefully, this is 1, 2, 3, 4, 5 and 6 wave cycles are created in 1 second. So, in the first case, frequency of the wave is 3 waves per second. Here 4 waves per second and here 6 waves per second. In short, we can say frequency is number of wave cycles. This is number of wave cycles or number of oscillations completed in 1 second is nothing but frequency of that sound wave. And this is denoted by small letter f and its SI unit is hertz. So frequency of the sound wave over here is 3 hertz. In the second case, frequency is 4 hertz. And in the third case, frequency of this sound wave is 6 hertz. Always remember relation between the frequency and time. So frequency and time are inversely proportional to each other. So that we can say frequency is equal to 1 upon time and time is equal to 1 upon f. Here is homework for you. must write questions and answers from the textbook exercise from question number 1 to question number 5 after reading the text. We will meet with the further details in the next period. Till then, keep on studying with whole music of your life.